Okay, so this will be on the cover of your flip book. What I want you to do is, on the left side, I want you to draw a circle and make sure it looks as perfect as mine. You guys know how to draw a perfect circle? Have I taught you yet? So kind of like Algebra 1, we learned our quadrants. You have the same thing here. The quadrants operate the same way. Quadrant 1, we move counterclockwise, 2, 3, and then 4. And since we are dealing with a unit circle, what's my radius? What's the radius in the unit circle? 1. So we'll locate just a couple key points, since you already have the other ones. 1, 0, 0, 1. Just like graphing, here's your y-axis and here's your x-axis. So it follows the same rules. Okay, so what we're going to do is I'm going to ask you a couple questions based on what we just did, and I'm going to challenge you not to look at your unit circle. Because the goal here is you're going to have to, I'm going to give you a question, and you're going to have to think about the unit circle in your head and visualize it. So that's where we're going. So here's the question I'm going to ask you. So go on the right side. Find the coordinates of the following location. All right, so I'm going to give you a location on your unit circle, and you're going to have to write down the coordinates. So for A, theta, this is the Greek letter, really just means angle. So the angle I want you to be able to write the coordinates for is 2 pi over 3. Now, I do not want you to look at your unit circle. Beautiful. Radical 3 over 2. Thumbs up if you agree. Okay, and if you need to reference your unit circle, that's fine, but I want you to get in the habit of, you're not going to have a unit circle on the test. You've got to have this in your head. Here's how I want you to think of this. When you're visualizing it, draw a little circle. And 2 pi over 3, 3's are closest to the y-axis. It's going to be right about here, right? And you know that's going to be negative 1/2 radical 3 over 2. Okay? So that's kind of the picture I want you to create in your head. You don't have to draw the whole unit circle. Just kind of 2 pi over 3. It's right up there. Okay? Let's try another one. All right, let's do part B. How about 7 pi over 4? Write this one down. Debbie, what did your group come up with? It's actually not a rad 3 over 2. It's a quarter. All the quarters have the same. Raphael. You got it. You'll notice all the ones that are over 4 will always have the rad 2 over 2. That's your 45, 45, 90. And here's the picture I want you to draw. That will help you visualize it. It's right about in the middle. Right down there, 7 pi over 4. Okay, now you guys are going to get better at this. We're going to do tons of practice. You're going to have this thing memorized. But what happens if I don't give you something that looks like this? I give you something different. Like this. Theta equals 7 pi over 3. Now, think about the unit circle. And then this is a little bit of a review. So you're going to subtract 2 pi. And the reason we're doing this is because this is one revolution around. You end up in the same place. The problem with doing this arithmetic is you can't do it unless you have the same denominator. So what do we need to multiply this guy by? Not just 3. 3 over 3, which is the same as the number 1. We've been big on this in this class, talking about keeping the value but changing the way it looks. All right, multiply this out. You should get 6 pi over 3. So it's 7 pi over 3 minus 6 pi over 3. You guys go ahead and do that math. Theta equals pi over 3. So here's the crazy thing about this. These two numbers, are they in the exact same place? Yeah, and it's pi over 3 on your unit circle. What quadrant is it in? 1. Figure out the coordinates. And the answer to this one, I'll give it to you. 1/2 rad 3 over 2. All right, there's the answer for this one. This next one I'm going to have you guys do totally on your own. You're going to have to think critically about this, but based on the one we just did, you shouldn't have too hard of a time. I'll try to fit it on here. And there's different approaches to this. So let's say theta equals negative, you have to remember what a negative does, pi over 4. Work on this one with your teams. I'll give you... Okay. So negative pi over 4 plus 2 pi, and you multiplied it by 4 over 4. Raise your hand if you also did this. Only a couple of you? Okay. And 4 over 4 was what? What did you get for 4 pi over, or when you multiplied it out?
Oh, I got 8 pi over 4.
8 pi over 4? So what's 8 pi over 4 minus pi over 4? 7 pi over 4. Have we already done this one? Yeah, it's part B, right? Now, so this is the answer, right? We've already done it, but the question is, how do you get here, right? Here's one way to do it. Add 2 pi. What's another approach? Moy. Okay. You rotate the opposite way, and why do you rotate the opposite way? Yeah, the negative value tells you to go the opposite. So if we're moving pi over 4 backwards, we actually end up right here, right? Because we're going backwards pi over 4, which is the same thing as 7 pi over 4. There's even another way to do this, which we talked about in chapter 1. Does anybody remember? It has to do with what a negative does at the graphical transformation. You flip it, but where do we start with that then? You start at pi over 4, right? Which is here, and a negative means you... Do we end up at 7 pi over 4? So here's 3 different ways to approach this. I don't care how you do it, whatever makes most sense. If you're really good at graphical transformations, this might be a good strategy. If you're good at algebra, this is probably a better move. Okay? Questions?